So my name is Dr. Micheál Scanlon. I'm a lecturer here at in the Chemical Sciences Department at the University of Limerick, and I've set up an electrochemistry group at the Bernal Institute. It has everything we need to allow our project to succeed. So in my research I make materials at water-oil interfaces, and this institute has a whole range of characterization techniques to allow me to characterize the materials I make. So very advanced techniques like X-ray photoelectron spectroscopy, NMR, X-ray diffraction, and very advanced microscopy, so scanning electrochemical microscopes and transmission electrochemical microscopes. So these are not part of my group, but they're part of the institute as a whole, so I can carry out much more advanced research by using the facilities available to me here in the Bernal. So here at the Bernal, where I make my advanced materials, we're going to use them in solar energy conversion and storage. This is a key technology because renewable energy is created intermittently. On a very sunny day, you'll have more solar energy generated. On a very windy day, you'll have more wind energy generated. And the electricity created using these processes can sometimes exceed what we need. And a lot of that electricity will be lost. It will directly go into the ground. So we need advanced materials in order to store that energy. And you can create advanced materials for lithium-ion batteries or redox flow batteries. Or in our case, we would like to also create materials that allow us to turn the electricity from renewable sources directly into chemicals. So we're going to store the energy in electricity as chemical energy in a bond. So to do all of this, we need to both create batteries and to create new approaches to solar fuel generation, we need advanced functional materials. So recently I have been funded by both Science Foundation Ireland and the European Research Council as a starting investigator. This will allow me to create a new lab here in the Bernal Institute, and in that lab I will have a whole series of technologies to characterize water-oil interfaces. One of my main research goals is to mimic artificial photosynthesis. My research is carried out at water-oil interfaces, and this is a mimic of a biological cell. A biological cell has a fatty part, a phospholipid, and that's the oil. And on the outside you have the water. And in biological cells you have molecules known as chlorophyll which absorb light. And that's what we're doing here. We're going to have an interface covered in chlorophyll-like molecules between a water and an oil phase. And we're going to mimic artificially photosynthesis just like it happens in a plant, except we'll do it here in our lab.